Hello, welcome back to another of the Richardson lectures on river landscapes in the UK. Today we're going to be looking at river erosion landforms. These are the features in the river's course that are created purely by the processes of erosion. The objectives of this session are to be able to identify and describe river erosion landforms and also to be able to explain their formation. So, river erosion landforms are created in the upper course of the river. This is where the river's got the most gravitational potential energy, pulling the river down towards the sea, giving it lots of power to erode vertically through the landscape. And what that does is creates these steep-sided V-shaped valleys. The river here, on this image, you can't really see it. It's a narrow channel, it's a very shallow channel, but it's got lots of vertical energy, and over time it's carved its way through the landscape to create this very steep-sided feature. Now, a related feature is something called interlocking spurs. This image shows a river. Again, it's a narrow river. We can tell it's in the upper course. It's surrounded by a steep-sided V-shaped valley. But here we can see that the river is actually winding around these fingers of rock that are almost jutting out into the channel. These are called interlocking spurs. And they develop because they are areas of harder rock. They're more resistant to erosion. And the river is trying to find its easiest course towards the sea, and so what that means is it winds its way around these harder areas of rock. And one from above, that creates this sort of zip-like pattern as the river's winding its way through, trying to find the easiest path, carving a route through these harder fingers of rock. We're now going to look at waterfalls and gorges, and we'll start by looking at this classic example of high force on the River Tees, which shows both these features rather well. So the waterfall here in the centre of the image, this is our vertical drop in the river's profile. And the gorge, hard to see here, is this vertical steep-sided valley that forms in front of the waterfall. And these two features are related. Now waterfalls form the upper course. They also need to form in areas where we've got variations in bedrock hardness. And this is a wonderful example that I came across in the Yorkshire Dales. This is Force Gill. What it shows, if we take a closer look at the rock types in this snapshot here, is that we've got this softer mudstone at the bottom, and on top of that we've got this harder sandstone. And the differences in the hardness of these rocks is what allows waterfalls to form. So we'll take a look at the processes that lead to the formation of waterfalls. So now we'll look at this sequence of formation. So first of all, the river's flowing over these bands of hard and soft rock. And as you can expect, the softer rock is going to erode more easily by those processes of abrasion and hydraulic action. So when the water does meet that soft rock, it starts to erode it via abrasion. The rocks in the water are grinding it away, and then we create this drop in the river's profile, our waterfall. Now, another sub-feature is created here at the bottom waterfall called a plunge pool. This is a deep pool of water that we see at the bottom that's created as a result of hydraulic action. The force of the water falling over the edge of the waterfall and crashing into the soft rock below carves out this deep plunge pool. Now over time, the river will begin to undercut the soft rock that's here under the hard rock. Water splashing back from the plunge pool slowly over time eats into this rock and creates an overhang. So the hard rock above is now no longer being supported by the rock below. And so you can probably work out what's going to happen next. Eventually, the hard rock collapses, it breaks off, it's not being supported, and is moved downstream. And what that means is our whole waterfall now has retreated, it's moved back upstream. And in its place, where the waterfall used to be, it's left this steep-sided, deep gorge in the river's profile. So now let's have a quick look at what that looks like from above with a plan view. And so as our waterfall is retreating over time, it's leaving behind this deep, steep-sided river gorge. Now we're going to take a quick look at that in a bit more detail with a hand-drawn diagram. So here's a hand-drawn diagram explaining the formation of waterfalls and gorges. And whilst exam boards don't often ask for you to draw diagrams in the exam anymore, they will be credited as part of a written answer. So here we can see we've got our hard rock sat on top of our soft rock, the water flowing over the edge of the waterfall and falling onto the soft rock below. And that's eroding that rock by the process of hydraulic action. So that's the force of the water crashing into the rock below. And what that does is it carves out this secondary feature, a plunge pool. So that deep pool at the bottom of our waterfall. And also in there, any rock material that's already fallen off from the waterfall above will be acting, grinding in the bottom of the plunge pool by the process of abrasion, helping to further deepen that pool. Now, water splashing back from the plunge pool onto this back wall here of soft rock is going to lead to undercutting. So this part of the waterfall gets undercut by that water. And eventually, the hard rock will not be able to support itself. It will collapse into the plunge pool and be broken down and eroded by those processes of attrition, and that material taken downstream. And what that does is, it means the whole waterfall is retreated back upstream. And so that leaves our secondary feature, a gorge. Now we're just going to finish off by looking at a quick exam question. And as with other parts of this topic, if you know your stuff, these can be really easy marks in the exam. So we've been given a figure here, figure 18, a photograph showing some features of a river in the Lake District. And the question is to explain how the landforms shown in figure 18 are created by physical processes. This question is wanting us to explain how the features shown here are created, what's their formation. Now, what's important is that even though after watching this video you'll definitely recognise that we've got a waterfall here, the question doesn't actually specify that there is a waterfall. So the first mark is there for being able to identify that feature from a source material, in this case an image. So you need to make clear reference to the figure, and with all these kind of landform questions I recommend starting by clearly stating what you can see. So a simple statement, in figure 18 there is a waterfall, and we can also see we've got a gorge in the foreground. The question does say landforms, so they want you to refer to both waterfalls and gorges here. Next, we need a clear sequence to explain how this feature forms. So you don't want to rush here, you want to take it step by step to make sure you include all the details that lead from that initial stage of having variations in the rock type right up until waterfall retreat, leaving behind a gorge. Now, also really importantly, this question wants you to specifically talk about the physical processes, so you must refer to the specific erosion processes involved and explain them. So you need to make sure you're referring to hydraulic action and abrasion and explaining what they are. Okay, so example here, the plunge pool is deepened by hydraulic action, which is, you know, that force of the water crashing into the bedrock. And if you follow that, you'll be looking at a 6 out of 6 answer. That's it for this video. Next time we'll be continuing our look at river features by looking at the features that are created by both erosion and deposition.